Welcome. This is the fourth video on our introduction to statistics. And in this video, we're just going to talk about sampling a bit and the common pitfalls that people run into. So, our first remark here is about generally what sampling is trying to do. And all sampling techniques are doing their best to promote an unbiased collection of data, and they're going to try to use randomness. At least that's what the best sampling techniques are going to do. And the goal is always to find a sample that is representative of the population. And we'll talk about some more involved methods later that will kind of use structures in the population. But the goal is always about finding a representative sample. So it might be ideal then, or make sense then, to define what we mean by representative. And ask yourself this question before you let the video go on. It's kind of hard word to define without using the word representative. But what I'm going to say is that a sample is representative if for all variables the distribution in the sample is proportional to the distribution in the population. And what do we mean by that is, say, consider a variable like age. And if in your population 20% of the people are younger than age 30, then in your sample 20% of the people should be younger than age 20. And this proportionality should exist for all variables and for all expressions or values of that variable. At least all the variables that matter or are related to your study. Another maybe geometric way to think about this is if your sample is, if your population is kind of like represented by this triangle, then your sample should just kind of be a smaller version of that triangle. So in this case, it would be like the side lengths and the angles are the same. Those would be like maybe the variables of consideration. But when you're talking about sampling a population of individual people, there's a lot more variables at hand. But maybe that picture can offer some visual representation. So when you are sampling, something that you're trying to avoid is bias. And bias is the opposite of being representative. And bias in this case doesn't necessarily mean an individual's bias, like a personal bias or a prejudice that people have. For example, the first one we have here, measurement bias, is a systematic favoring of a particular result. So the example I have here is that a scale that weighs heavily. That doesn't have anything to do with an individual prejudice, but it's still considered bias in the context of sampling. If you're trying to weigh seals, but that you always weigh heavy, then you are going to produce a biased average weight of seals. But it's not because like an individual, a personality thing. It's just a type of bias in your collection of data. So the rest of these it's important to keep that separation in mind of the way bias is used in everyday language and how it's maybe used in this more statistical fashion. So the rest of these we have selection bias, where some definable subset of your population is more likely to be in your sample than others. A non-response bias you can think about in the context of surveys. So if you make a bunch of phone calls and you're trying to get people to answer your survey questions, but only 1 out of every 20 people responds, there's something untrustworthy about your data. There's some bias going on there, and we're going to call that the non-response bias. That's in opposition to the response bias, where there's some effect of you collecting the information. And again, I think thinking about a survey is a good example to consider a response bias. The wording of a question can affect how people respond. Or when we talked about ballots, how you list the people on the ballot can affect what people vote for. So the first individual on a ballot maybe gets an advantage because they're the first one there. And then finally, let's just talk about some common sampling techniques that have issues. And the first one here is the convenience sampling, where researchers just choose the easiest subset of the population to be in their sample. That's just picking the people that are nearest by. And what's wrong with this is some kind of selection bias. Right for a selection bias. Because there's a definable subset of people who are more likely to be in your sample than others. That's the people who are convenient to your selection process. So, if you are doing a study in a psychology program, then it is convenient to pick people on campus, but you need to be careful about who your population is, because you're not getting a representative sample of everybody in society because you're only sampling on a college campus. Volunteer respondents may not be representative of the population as a whole as well, and that's another type of selection bias. Because people who want to volunteer for a study may fit into a special category, especially if there's money involved. If volunteers are financially rewarded. Financial compensated. Because people who are in higher need of having that money are going to be more likely to respond. And then finally, there's this concept called quota sampling, wherein you set quotas on how many of a different group on a certain demographic that you would like. So this seems good because you're trying to make seems good because you are trying to make a representative sample. But these issues with constructing the quotas is always going to be imperfect because there's always going to be more variables to go after. And then when you're just trying to fulfill the quotas, you might rely on convenient sampling, for instance. So that's it for this video. We just discussed what representative means in terms of a sample and common issues in sampling. And the next video, we'll discuss some good sampling techniques. So see you there.